right. Hello, great Nance. How is everybody doing? If you're just drop a quick hi in chat. Um, how was your weekend? Mm, Was the weekend okay? Mic is on. Okay. All right. That's cool. Cool. Um, yeah, it was kind of cold. It was weird, eh? This weekend. Oh, it is what it is. Um, who's that? Brandon. Hello. How's it going? Good. Nice to hear. All right. Let's just quickly check out, what our plan is for the week ahead. Today we'll be doing, well, obviously we'll start our electricity unit, but we don't have enough time to finish. We'll do what we can. This is for my grade 11s. Let's go to our grade 9 class here. Okay. So we're gonna essentially have only 3 days of class. Um, on Wednesday we will have our final class per se. There'll still be time for you to ask me questions and like kind of check in and see how everyone's doing. But that's kind of it. So on the Monday today we're gonna be talking about conductors and insulators. Tuesday we'll talk about energy production. So kind of like where do we get our power from to use in our home for electricity. And on Wednesday we'll talk about what are some small things we could do to kind of like reduce our impact and like kind of be more conscious of like our environmental impact, our environmental footprint in the case of conserving energy. Okay, and then on Thursday and Friday there will be a summative. I don't know what it will look like. Maybe I'll get you guys to research something small and submit it back to me. Uh, maybe it yeah, like it'll be something small. Keep an eye on it. I'll post it probably on Wednesday. It will be due, let's say by Sunday. Because I'm gonna submit marks on the Monday, so it is what it is. Okay. So today we're gonna be talking about conductors and insulators. Short lesson. But you know what? We gotta do it. Short and sweet. Let's have a look. Where are my conductors? Here we are. Okay. So, you probably heard about them before, conductors and insulators. Maybe, like certain materials are better at doing certain things than others. Some things are used for safety. Some things are used because it's really good at moving charges, things like that. Okay, so the first thing we want to talk about is the insulators. So, what is an insulator? An insulator is a substance in which electrons cannot freely move. So they cannot move very easily. An insulator will kind of stop or be very difficult for electrons to travel. Imagine like insulators are like if you have a pipe with running water in the pipe, an insulator makes the pipe narrower. The water might still be able to go through, but it's gonna slow down. It's gonna make it hard for the water to come out. That's what it is. An insulator makes it difficult for electrons to move. These objects, insulators, tend to be non-metals. So something that's non-metal tends to be a bad conductor, or we call them insulators. Okay, if some atoms of an insulator become negatively charged, those electrons remain. So the big thing with insulators are charges do not move. Do not spread. Do not spread out. Large charges can be built up the same way, like if you have carpets at home, or if you have, I don't know, if you ever take off your sweater, or like kind of when you're leaving a car. Your charges can build up on your body, or it can build up on fabrics. And we know that because when we test something metal, right after the charges build up, we release those charges very quickly to the metal. So examples here are carpets, paint, wax, especially in winter. But there's a use for it. Like you might be saying, okay, they're not good at conducting electricity, but they're good at protecting us. So whenever we work with electricity or maybe hot objects, we like to wear insulating materials so we stay protected. Okay. So an example would be if a plastic ball got some charges. those charges would stay put. Uh, an insulator does not allow movement of charges. Those charges do not move. And it's weird because if those are all negative charges, they don't like each other. Positive will be attracted to negative. Positives and positives don't like each other. They want to go far away. Negatives and negatives don't like each other. They want to go far away. But it's on an insulator. An insulator says you are not allowed to move. Eventually, they can be removed by another process, but they are not allowed to spread out on an object. Okay, vice versa. What is a conductor? A conductor is something that allows substances to move very easily, or sorry, electrons to move very easily. So, in the same pipe analogy, it's like having a nice pipe that is smooth all the way through, where the water flows quite easily. There's no restrictions here. It's very good at making the water travel from the left to the right. If a conductor becomes negatively charged, here's the important part, the charge will want to spread out. Because the material allows for the movement of charges, well, let's say even if we started off the same way, like this one over here, if we started off the same way, let's crop. Won't let me crop. Will that object? No. Oh, that's interesting. That's okay. We'll ignore that plastic where it says plastic ball at the bottom. Let's say it started off this way. If it started off with the charges in one spot, eventually, because those charges don't like each other, they will spread out, so that they're as far away from each other as possible. They want to stay far away from each other because they're the same charges. Okay, so what are some examples of stuff? So good conductors, where did this come from? See you later. Good conductors tend to be metals. Things that are metal tend to be good conductors. All these ones over here on the opposite end are good insulators because they are non-metals. So something like rubber, glass, plastic, wood, paper, we know that they don't allow charges to move very easily. Things like copper, silver, gold, aluminum, magnesium, these are actually also what are used in wires because we want the electrons to travel quickly. So if you ever, I don't know, cut your iPhone charger or whatever, cable, you would see that there are nice copper wires in there because it allows for electrons to move very easily. And we want to have that in certain places. And you'll also notice that, well, why isn't the wire just copper only? We coat it in plastic and rubber so that it's safe for our usage. So when we go up to pick up the wire, even though it's plugged into the wall, we don't get shocked because, well, of that insulating plastic and rubber around the wire. And now these ones are kind of in the middle. They're sort of conductive, but not the best conductive. Earth, Earth as in the ground, is a good, decent conductor. Salt water, moist human skin. So if your skin's wet, that's actually kind of dangerous, right? We don't want to handle any exposed electronics because then we can get shocked. Okay, so metals have a weak hold on the electrons. They aren't able to hold the electrons very well. That's why heat and electricity is able to pass through it so easily, because they don't have a strong hold on the electrons. Non-metals do. They hold on to the electrons very tightly. This goes back to when we talked about, certain elements want to lose electrons, certain elements want to gain. So it turns out metals lose electrons because they don't hold on to them too tightly. All right. Vice versa for nonmetals, they have a tight hold on the electrons, so they don't want to move them around. So you won't use them as conductors. Okay. The last thing we want to talk about is discharge. What if something gets a lot of charge on it? What happens? Well, eventually that charge will build up and then jump. We see that in two ways. We can see that, well, in nature, it's lightning. What happens is that we have, let's draw a little picture real quickly. Picture. We'll draw a quick picture. Okay. So what happens is we have our clouds in the sky. Here's the ground. Maybe we have a nice tree as well. Whatever. Yeah, nice. Okay. Now, as the cloud is traveling in the sky, eventually it might build up some excess charges. Now, if it becomes really positive, if it gets too much of a charge, there might be a lightning strike, which allows some of the charges to leave. Or vice versa, if this one became really positive, it would actually, the lightning strike would be from the ground to the sky, which happens. Not as common as sky to ground, but it would suck up some electrons to balance out those charges. So here, those electrons would go up the lightning bolt to equal out the charges. And that's how they balance out again. The same way when we are in winter, we have socks on the carpet, and we touch a doorknob, that's because we're charged. Either if we are negative, we will shoot electrons out of our finger into the doorknob. If we are positive, actually it's cool because the electrons come from the doorknob and they will go into our finger and balance us out. Either way, it will balance out. That's what discharging means. It's a buildup of charge and then losing that charge really quickly. So, it's not a good thing or bad thing, but it could be dangerous. We know that obviously, just a little static charge or little static spark at home, that's whatever. If you've ever taken off your a hoodie or sweater in winter, and if it was dark enough, you might be able to see the little blue sparks. That's static. The charges are too high, so they shoot around to kind of balance out. Hey Mo, how's it going? You might be in the wrong class. We finished our 11 class a little while ago, but thanks for dropping by and saying hello. How kind of you. Okay, so how do we stop that charge in case it's dangerous, right? Because, us taking off a sweater and seeing some sparks getting shocked by a doorknob or by the door of a car, not so bad. However, let's say if there's something flammable nearby, we could start a fire. How do we be safe about that? Well, we do it through what's called grounding. If we have a direct connection between us and the earth, we won't shoot sparks out onto other objects. So, a grounding wire is literally a wire that's connected to the ground. So, you may have noticed in your house, you have electrical outlets. That looks something like this. Yeah, little faces. These are the live wires, the eyes, and the mouth is what's called the ground. And especially if you have something that takes a lot of power, it will almost certainly always have this. It's not necessary, but if it has the little third prong, the grounding wire, it means that if for me, my computer tower, it has one of those. So it saves or it preserves all the electrical components inside of it, because if there's a charge that builds up, it will go to the grounding wire. So none of the electrical components in my computer will fry up. Now here's some examples. Well, in our home, no, it's okay. Don't worry about it, Mo. Not a big deal. If lightning were to strike our home, well, our home is normally made out of wood and bricks and stuff like that. We don't want the wood to catch on fire. So if lightning strikes, normally it will strike something metal, like on our chimney, or if you have an antenna. And those antennas will be attached by wires that will lead directly into the ground. So we want to take the electrons away from the house and send them straight to the ground. Same thing when if you ever see those oil tankers filling up at a gas station, so where they're putting the gas in. So at the gas station, they have a big tank of fuel that's underground. They have to put that oil into the ground, the gas. Gasoline. They have to put the gasoline into the ground. But once again, a small spark could start a big fire. So what they do is that the technician will ground the truck to, the earth, so to make sure that if there's any charge, it will go to the ground directly. There won't be a spark between maybe the person doing the pumping and the car itself. And the same thing goes for when you fill up gas at a gas station. You should just quickly touch your car. Just in case you have any excess charge on you, you can take away that charge by touching your car. You might feel a shock there, but it's better to have the spark between you and the car versus, let's say, you and the fuel. And now you light the fuel on fire. So, no good. The other way is, well, we might want to ground, but how would you ground an airplane? Imagine if an airplane gets struck by lightning. We don't want that lightning to mess up the electronics on the airplane. So they have what's called discharging at a point. So they have these little tiny, tiny things at the end of the wings called, well, discharging pins that allows the air to take away the charge. So if we have really, really sharp points, remember, metal likes to spread out charge. Those little tiny points will be able to pull away the charge really quickly. Okay, that's all for today. Today we just covered what are good conductors, what are good insulators, what are the differences between the two of them. We gave some examples, and we also talked about discharging. So when we don't want charges to travel or sparks, how we can safely, not well, our house doesn't catch on fire if lightning strikes it, or how to safely fill up gas, or even on airplanes, how they handle excess charge. Tomorrow we'll talk about, well, how do we get electricity in our homes? Where does it come from? Okay, we'll cover that tomorrow. I wish everyone a wonderful afternoon. All right, ciao everyone.